It don't matter where we go, it don't matter where we stay tonight.
Moving on to the next session, we have Director of Capgemini, Apala Singhal. She is gonna say about how to start your cloud journey. So this is the most exciting ones for all the beginners out there. So telling much about Apala, she is a digital transformation leader. She has an extensive delivery management experience, working in different niche technologies and handling big global teams. She has handled complex agile engagements, focusing on program management, activities like finances, planning, executions, and stakeholder management using different technologies. So this session is worth for you all to listen. Let's have Apala with a huge round of applause.
So guys, Apala is going to join us through virtual meetup. So like she couldn't be here in person, but there she is. Enjoy the session then.
So there are 3 steps which are involved if you are a beginner and if you want to go to intermediate state. Now many of you might already be working onto Google Cloud, or some of you might be having very basic idea about cloud computing. Whatever stage you are in, there is a 3-step process from coming to beginner to intermediate level. And once you reach up to intermediate level, the next thing what you need to do is that you need to have real-time project experience, and you need to do lots of hands-on activities to come to advanced level. So now let's understand that if you want to come from beginner to intermediate, what are the 3 steps involved? So the step 1 is that you need to learn the cloud computing concepts. The second step is that why our organizations are using cloud computing. The very basic thing, the mistake which people used to do, they directly jump to step number 3. They choose any cloud provider services, they start learning it, and then what happens, they come across many terminologies and many concepts which they were not clear on those things, and that's where they go back, they keep coming here and there, and that's why the time to complete this learning, their entire learning journey becomes even more longer. So we will understand that what are the things which you need to understand if you want to learn it in the most optimized way. So even if you are a person who has some experience onto it, but if you feel that step 2 might be useful for you, because here we will be talking more about different use cases where cloud services are implemented in organizations, then this talk is going to be useful for you as well. So let's get started with the first step, cloud computing concepts. So first of all, if you decided that you want to create any applications, what are different resources you would require? You would require computing resources like virtual machine, operating system, then you can create web servers, your application server. From the networking side, you will require sources like firewall so that the unwanted traffic does not reach to your application, routers, so that the traffic can be routed to the right server. You will require switches, and then you will require load balancers so that the traffic is distributed across the servers and it is not loaded across only a couple of the servers. If you are working on the application, you might be having some data. Now, depending upon type of data, there are different storage options, and that's what you need to take into consideration when you are creating an environment for your application development. If your application is about big data, then you will require Hadoop or any counterpart of it. You would require data warehouse, and if your application is in machine learning, then you will be using this data for training the machine learning models. So in short, you will require so many hardware components like server, networking, storage, and in order to procure this, there will be a huge cost of procurement called capital expenditure or CapEx. Once you have procured all these components, then you need space to keep it. You will require electricity to run it, and also for ventilation purpose, you will require electricity and many other maintenance aspects, which is called the cost of maintenance or operational expenditure OPEX. Now consider This is the era where so many tech startups have emerged. In the last decade, 10 to 12 years, many new tech startups has emerged. Is it that 15 years back or 20 years back, people were not having good idea about startup? It was not the case. The problem was that if they wanted to set up their environment for development, it was very costly affair. Why? Because there was a huge OPEX, huge CAPEX was involved. And if those people were not able to get the funding, it was very difficult for them to go ahead and develop such application. But with the advent of cloud computing, it has become very easy. How? So the thing is that if somebody is given an option that you can get the infrastructure and you can use it as and when needed, and even you don't need any space to keep it, and also if you want to reduce maintenance overhead, which will reduce your OPEX, isn't it a great choice? And that's exactly what cloud computing provides to you. So what is cloud computing? Let's understand that with the help of NIST definition. So this is a big definition. So what we will be doing, we will be breaking this big definition into small chunks so that it is easier for us to understand. So first thing is that cloud computing is a model for enabling. Now what is model? Model means it has got certain principles defined. And every cloud provider who is providing the services, they need to adhere to these principles. So it can be any of the cloud provider, like it can be Azure, Microsoft, Azure, or it can be AWS, it can be Google Cloud Platform. Any cloud provider, if they want to provide their services, they need to adhere to these principles. Sorry. The next aspect as part of the NIST definition of cloud computing is that you should be able to network access these resources. Network access means you can access these resources through internet. Then it is saying that there is a shared pool of configurable computing resources. It means there is a pool of resources, and depending on your requirement, you can access these resources. But once any resource is being accessed by any one user, that resource will not be used by other user. But once that resource is made released, it is not in use by any other resource, any other user. In that case, it will be made available to other users. So that is the shared pool of configurable computing resources. Now the third aspect, what it is saying, that the resources can be rapidly provisioned. Now consider the old time where you had to procure the servers and all. It used to take months, and even today it used to take days, because once you get it, you need to configure a number of things over there related to networking and all other softwares and everything, and it used to take days to actually get it into action. Whereas when you are working onto the cloud, it just takes minutes to get that provision, that particular resource, and you can start using it. So that's why it is said that if you are working onto Google, any of the cloud, the resources can be rapidly provisioned. Another important aspect is that minimal management effort. It means that when we will be going ahead with the shared responsibility model, and with that we will understand that there will be a shared responsibility between the user and the cloud provider. And another last aspect is that service provider interaction. If you want to use any cloud provider service, you don't have to interact with their service provider people. You can start using it through any UI, and it will be very easy for you to go and connect and start using those services. Now there are different service models. Now the question comes that why there are various service models. Now there are different kind of users, and for different kind of use cases, which we are going to discuss in just a couple of minutes, there will be different types of requirements. For example, there might be some system administrators who want to ensure that they are configuring the virtual machine from scratch. They want to put their own choice of operating system and all those things. That's where they will be going ahead with the infrastructure as a service. Second is that there are some developers. Developers are not bothered that how the operating system is installed. They are not bothered about how the runtime environment has been created. What they are only worried about that how they want some environment where they can write the code and they can build it. So that is your platform as a service. Another one is software as a service. That is for the users who are not worried, who don't want to go for any infrastructure aspect, any maintenance aspect, writing any code. They are only thinking about, I want to use a particular software and they want to use that only. So that's where it comes about, software as a service. So for depending upon different types of users and their requirements, there are different service offerings, which is called cloud computing different service models. So what is that? Let's understand that in which scenario, which service model is more suitable. If you want maximum control on the virtual machine, that's where you should be going ahead with the infrastructure as a service. Then another one is scalability and availability. Scalability and availability are two non-functional requirements which are, anyway, if you are using infrastructure as a service or platform as a service or software as a service, it is achievable. So that's one of the reasons we will be understanding later, that very easy to achieve when we are working onto the cloud. Next is that automatic software update. If your requirement is that you don't want to go ahead and update the softwares over there by your own, then infrastructure as a service is not your choice. Then you should be going ahead either for PaaS or for SaaS. Another thing is that you have a developer who wants to develop application, but the person does not, he doesn't want to take any headache for maintaining the virtual machine. So in that case, for him, the PaaS will be the best option. At the other hand, if there is any other user who is not at all worried about that, what the infrastructure is, how the code was built, and how are maintaining it, they are only worried about the software and the features they want to use. In that case, they should go for the SaaS. So this is a quick comparison between these services. So with that, we understood that what is cloud computing. Now, very important aspect is now that why organizations are using cloud computing. So first of all, if you are here because you want to learn cloud computing. But why do you want to learn cloud computing? Because there are organizations who have such requirements. And why organizations are using the cloud computing, that's what we are going to understand now. So there are different use cases for which the cloud computing is being used by the organization. We can broadly categorize them into two categories. First is that cloud computing, cloud provider services helps you to set up your work environment in a very easy way. At the other hand, there are some non-functional requirements, and you can achieve the SLA of non-functional requirements using the cloud services in a very easy manner. So we will first talk about that, how it is easy for you to set up work environment. We talked about the startups, that why so many startups are emerging now. Because with the help of cloud computing services, cloud providers which are providing, with that it is very easy for you to set up the work environment. So let's understand that how it is easy. So first is that the VM for web servers and application servers from cloud. Now suppose your requirement is that you want to create a web server or application server, and then what you will be using? You will be using infrastructure as a service. So from the Google Cloud perspective, you will be using compute engine. Now another requirement is that there is a developer who is not bothered about that, how you are setting up infrastructure, how you are making the runtime environment available. He is only worried about that the person wants to have some runtime environment where he can write the code. So that's where he will be using platform as a service, and App Engine is an example onto the Google Cloud platform. Another use case is that if you want to use managed database. Now, what is managed database? So suppose if consider the case of traditional computing. In the traditional computing, if you had to set up a database server, you will require any hardware for that. You will install the operating system on it, then you will install database on it, and once it is done, then you will have to do other things, like you need to create replicas, you need to create backup, and in case of any revisions onto that database, you need to keep on updating it. So and apart from that also, there are so many other maintenance issues and maintenance activities which a person has to do, a database administrator used to do if the person is doing it onto the on-premise. But if you are using the cloud, in that case, cloud provides managed databases. and they provide it both for the SQL as well as NoSQL databases. So from the GCP Cloud perspective, it is Cloud SQL and Cloud Spanner are for SQL database. Data Store, Firestore, and Bigtable are for the NoSQL database. So you can very easily go and start using managed databases without worrying about its overhead part of it. Another use case is databases with specific licensing requirement. Now, when we talked about the managed databases, it comes with a particular set of some databases, and that too with a particular version of it. Now, maybe your client might be having some requirement that they want to use some other database, and if the database is there, then maybe some version is there which is not supported as part of your managed database. In that case, what you need to do, that because there is a specific database requirement which is not supported by cloud provider as part of managed services, you need to provision a virtual machine, then you need to install database on it, you need to configure the database, then you need to update database licenses as and when needed. So effectively here you are using infrastructure as a service, which is your compute engine, and on top of it you are installing all those things. Another use case is, suppose you are developing an application for analytical purpose, and for that also there are multiple server requirements of different types, because it is referring with big data. So first of all you need to store it, so you need some server with high storage capacity. On the other side, because you need to process this data, so you will require high processing power servers, right? Consider the case of traditional computing. If you had to create such environment on premises, in such case, it will be very costly affair for you, because you need to buy it, you need to procure it, and then only you need to set up, and then you need to maintain it. So its capex and opex was very high. Whereas now in case of cloud computing, it has become very easy. So you just need to pay and use. So as per usage, you will have to pay, and you can use it as per your requirement. You can put it as per your storage capacity, you can put it as per your processing power requirement, you can get the servers, and you can start using it. So you can use the managed services over here, and those are BigQuery and Bigtable in the case of Google Cloud. Now coming to non-functional requirements. There are many non-functional requirements. So whenever we create any application, there are functional requirements on which people work on. But apart from that, there are many non-functional requirements also. And as an architect, when a person designs the application, the person takes care of all the aspects of non-functional requirements and ensure that SLAs, which is service level agreement, which is mentioned for each and every non-functional requirement, that is also met. And accordingly, the architect designs the application. So what are some of the very important non-functional requirements? Those are scalability, performance, security, and availability. So let's talk about all these non-functional requirements and see that how we will be able to achieve it very easily onto the cloud. So for example, there is an e-commerce application, and your e-commerce application is hosted onto the cloud on multiple virtual machines. Okay, and there are consumers who are accessing, so there is some traffic which is coming to it. Now now when we talk about scalability, what is scalability? Scalability means ability to handle varying workload. But why the workload will be varying? So for example, there is a weekend, or there is a Black Friday sale, or there is a festival season, and so there is some sale onto that e-commerce site. So in such cases, there will be more traffic going to that e-commerce application compared to other days, normal days, right? In that case, the traffic which is coming to the application, the servers onto which the application is deployed, they might not be able to handle the additional load. So in such case, what you can do, you can set up auto scaling, so that additional VMs will be spinned up, and then your additional traffic will be handled by these additional VMs. And once that sale is gone and traffic is reduced, you can shut down the VMs, you can release them. So that's how you can easily get the scalability incorporated into your application, and you can meet SLA, because spinning up VMs onto cloud is just, it is rapid provisioning. That's what we discussed when we talked about the cloud computing fundamentals. Another important aspect is the performance aspect. Now, what is performance and response time? Suppose you are a user and you are accessing any e-commerce application. You sent a request for, maybe you want to know the product details, and you got the response after 1 year, and that is the pattern which is happening there all the time. Are you going to continue with that application? Definitely not, because there are other e-commerce applications in the market and you can switch to other one. So if your application is having this kind of performance issue, then definitely your business is going to get impacted, because your users are moving to other competitors and they are leaving your application. So performance is a very important aspect, and we need to ensure that our application is performing well. So now the question comes that how will you ensure that your application is performing well? So there are multiple ways how we can improve the performance of an application. So first one is that you can use read replicas. Now, what is a read replica? So there are multiple ways to enhance. So one is the use of read replica. So what you used to do that the main database which you are having, that's where you can send only write and update query onto the main database, and then you can create read replicas which is replicas of the main database, and you can send read replicas. So improve the performance of your application. Another way to improve performance is CDN. Now, what is CDN? CDN is Content Delivery Network. So what it does that we will understand it with the help of an example. So suppose there is an application which is hosted onto the cloud, and this cloud is in this data center in Canada. Now there are other data centers also onto the same cloud. There can be data centers in Singapore, it can be in New York, it can be in Mumbai. And now there is a user who is in Australia. He sends out a request because he wants to access this application. So the request will go to the nearest data center. So in this case, the request will go to Singapore. Now it will check whether there is any, for static data, whether there is any data cached over there in Singapore data center or not. If it is not, then the request will go to the data center in Canada, and then the response will go back into the data center in Singapore. From where the request of the client will be served, but at the same time, the data which has gone from data center in Canada to Singapore, that is going to be cached in the Singapore data center. Now, if there is another client who is also trying to access the application, for him the request will not go to the Canada data center. It will be served from the cache which we are having onto the Singapore data center. So that is how you can improve the response time. Another thing is that you can improve the performance of an application using the in-memory cache. So memory store is, Redis is there, memory store is from Google Cloud. So for example, there is a search query, so that will go to your main database. So what you can do, you can create a cache onto the Redis, which is temporary in cache memory. And then further, if there is another same search query comes, the hit will not go to your main database, it will be served from your in-memory database, which is Redis. Or if we talk about the Google Cloud, it will be memory store. So that is how you can improve the performance of an application. Now coming to the security aspect of it. So we talked about that there are different shared responsibility of security between the cloud provider and the user. Now depending upon that what service model you have selected, the responsibilities will differ. If you are using infrastructure as a service or platform as a service or SaaS, in such cases the responsibilities are going to be changed over here. Apart from that, there are three very important aspects of security. First is that when your data is moving from the browser to your end use TLS. Another thing is that when the data is at rest, so Google Cloud ensures that whatever data is at rest, it means data at rest means it is saved onto any of the storage or on the databases. So in such case or anywhere, if it is saved, stored over there, it will always be encrypted before it is saved. It is persistent. So that is one of the very good feature of Google Cloud, what it provides, the encryption before the data is persisted. Another important aspect of security is IAM. Now, this is a part of access and role management. So what you can do, you can create different roles, and for those roles, you can give different kind of access. Now, to the user, there are multiple users. Now, depending upon their role, you want to allow them certain access. For certain users, you only want to allow view access of your application. For certain users, you want to allow edit. So in such cases, depending upon their role, you can allow different kind of access to users. Apart from that, there is very important aspect over there, which is about availability. Now consider a case that there is an application which is running, and it can be running onto the on-premises or it can be onto the cloud. Now when the user tries to access it, the request will go to load balancer, and from there the request will go to the main site. Now consider there is some problem at main site and entire main site is down. In that case, your application will not be available, and any user from any part of the world, if they are accessing the application, your application will be down. But definitely this is not the scenario what we want. We want that all the time my application should be up and running. So how should we achieve it? In that case, what we do, we create a disaster recovery or backup site. Now, depending upon the SLA of availability, we define that what kind of setup we need to create on the DR side. And then in case of disaster, the request will be routed from load balancer instead of main site to the disaster recovery site. So this is how we can achieve the high availability. And this helps us to ensure the business continuity, and also it helps us to increase the uptime of my application. Another use case of this cloud computing is production scale testing. Now there are, you must be knowing that whenever we create any application, it goes through multiple rounds of testing, right? And then it is deployed onto production environment. Now, what happens that on the production environment, multiple servers are there and lots of traffic is coming and all. But when we perform the testing over there, testing is not performed with the same load with which the real traffic is coming into production. Why is it so? Because if we want to test it at that level, it will be a very costly setup for us. But now with the help of cloud computing, we can create a similar environment as we are having onto the production. Same production-like environment we can create for testing. We can test it, and once done, we can release all the resources. So that will be a very cost-effective way of production scale testing. Now we are done with step 2. So it means we first understood the cloud computing concept, then we understood that what are different use cases, how and why organizations are using cloud computing. Now the third step is that you need to choose that which cloud provider you want to go for. For example, you have selected Google Cloud. Now if you want to learn Google Cloud, how you should be learning it now? First thing is that whatever services your Google Cloud is providing, you need to categorize them under different categories, like whether those services are related to networking or they are related to compute or data storage or data processing or data warehouse, or what exactly that service lies into. So identify the category. Then the second aspect, which is mostly missed by most of the people, that map the services with the use case. As the step 2, we learned various use cases where in which the cloud computing is implemented by the organization. Now when you learn these services, try to map that this particular service is going to be mapped with which use case, and with the help of use cases, and that's where you will be understanding what is the usage of a service. And once you are done with that, you need to perform hands-on activities. You can start with quick labs, but then I would suggest that don't stop at quick labs, because quick labs is a simulated environment. It means that particular lab is to perform certain activity, but when you perform that activity, there are multiple settings which are done at the backend side, and you won't be able to do if you perform the same steps on the real-time environment, it will not work, because the backend settings which are done, you don't know about it. So I will suggest that first go ahead with the quick labs, get the understanding, and then move to the Google Cloud environment, because Google Cloud provide your some free time access also for certain time. So that's where you can use it. You can start using it through console or through Cloud Shell, and that's how you should be learning it. And with that, if you learn, your journey will be very short and it will be very crisp, and you will be able to understand. Now that is done. Now next thing is that there are multiple roles related to cloud into our IT organization. So what are those roles? So those are cloud infrastructure administrator, cloud developer, cloud solution architect, cloud data engineer, security consultant, and machine learning engineer. Now depending upon what is your aspiration, you need to choose that what is your role which you want to perform maybe after a couple of years. And in that case, there are multiple certifications available by Google Cloud, and you can target that certification. So that is how you should plan your career if you want to go into that. And even if you want to start your own startup, we discussed that how you can leverage cloud if you want to start your own startup. So with that, I would like to close this talk, and I hope you have got a good understanding about different use cases, how you should be learning the cloud in the shortest way and in the most efficient way. So keep learning, and all the best for your future. Thank you.